Okay, we're going to take a look at some advanced techniques for solving trigonometric equations here. Now, it's not that these are difficult, they're just kind of weird types of equations that you might run into um, as you get better at these. Right. First thing is not so much solving as it is what they're asking for. So when we solved an equation, let's keep things real simple here. Let's say cosine of x is equal to 1/2. Right? When we solve this, we start off with, okay, principal value. Principal value for this is the cosine inverse of 1/2, which we said would be 60 degrees or 5/3 if we're talking radians. Then I say, okay, what if they ask for between 0 and 360? So less than x, less than or equal to 360. Well, you always got to ask yourself, is the principal value an acceptable answer for 0 to 360? And the answer is yeah. 60 is between 0 and 360. But there is another place cosine is positive besides, quadrant 1, which is what we got with our principal value. So where else is cosine positive? Well, it's positive in quadrant 4. So let's go off to the side here. Quadrant 4, we'll draw a reference of a 60. And we get 300 degrees for our actual angle. And then just putting this in terms of radians, 0 less than or equal to x less than or equal to 2 pi. We would say 60 is pi thirds, 300 is 5 pi thirds. Right. Now, what else could possibly be asked of you? They might say solve for principal values. Got it. 0 to 360. Got it. 0 to 2 pi. Got it. Well, what else they could ask for is what is called all values. Solve for all values of the variable. Now, keep in mind the reason we originally restricted this between 0 and 360 is because we saw there are infinitely many solutions to an equation such as this. Where is the cosine graph going to hit the horizontal line y equals 1/2? Well, it's going to hit it infinitely many times. So that's why we had to restrict how we wanted our solution, because there's just too many answers to list. But there is a way we can list the answers, and it's not super difficult, but most of the time you just take your answers between 0 and 360, or if you are dealing with radians, and simply add a multiple of 2 pi. The idea is, if you remember coterminal angles, we talked about those a long time ago, you add multiples of 2 pi to that, or multiples of 360 if you're talking degrees. So if they said, okay, solve this, cosine of x equals 1/2, I want all the solutions. What are all the solutions to this? Well, if we're talking degrees, I would say it's 60 degrees plus every multiple of 360. That is 360k. So 60 degrees plus 360k, where k is an integer. Remember, integer, if I can spell. Integers, we're talking about, -2, -1, 0, 1, 2. This would cover all our bases. So not only 60 degrees, but every angle coterminal with 60 is what you're saying. Now, that doesn't cover 300. 300 and 60 are two totally different angles. So we have to go with 300 plus every single angle coterminal with 300 degrees. And this would constitute our solution for all values. And of course, radians, we got to alter this a little bit. For radians, we would say, okay, pi thirds plus every single angle coterminal with pi thirds, which would be 2 pi, that's 360, times k. Again, k is an integer. And we got to go with 5 pi thirds. Hopefully you can still see this down here. Plus 2 pi k. Every angle coterminal with 5 pi thirds. Yeah, you can see Right? So that's the idea when we're solving for all values. You just go with coterminals. Now, I don't want to say this is always what you do. Just take your 0 to 360 and do 360k, or pi thirds, 5 pi thirds, do 2 pi k. I mean, you can do that, but sometimes it's a little bit much to do it that way. There are sometimes easier ways to condense this. On this particular one, this is as good as it gets. But there are other problems out there where we can condense. So, for example, just show you one. Say tangent of x equals, let's go -1. And again, I'm just trying to get down to a simple equation just to show you how this all values thing works here. All right, we would go through the paces here. The principal value, we're going to say, is the tan inverse of -1. And make a long story short, we're looking at -45 degrees. We're in quadrant 4, or pi force, negative pi force, sorry. Negative pi force, if we're talking principal values here. 0 to 360. 0 to 360, we cannot use this -45-degree angle because it's not between 0 and 360. So we can still use it as a clue. So if we're talking a -45-degree angle, we would be referring to a 315 if you go positive, go counterclockwise. Right? So quadrant 4, question is, where else is tangent negative besides quadrant 4? And the answer is quadrant 2. So 45 degrees, quadrant 2 would be 135 degrees. And just finishing this off, 0 less than or equal to x, less than or equal to 2 pi. We would say, well, 315 degrees, that's 7 pi force. 135 is 3 pi force. And then finally, are all values, if they were to ask that. I don't want principal value. I don't want 0 to 360, 0 to 2 pi. I want them all. I want all the values, all solutions to this equation, every single one of them. Well, we could go the route of saying, okay, it's 135 plus 360k. And then 315 plus 360k. But you're going to find many books will not do this. They will not display their answer this way. And it's particularly, I would say, almost exclusive to your tangent, though that's not 100% true across the board. But when you're working with tangent and you do all values, these two statements can actually be condensed into a simpler form. And the reason is tangent's solutions, unlike sine, unlike cosine, they are 180 degrees apart from one another. So you can see from this picture, it's a 45-degree reference angle. Where is tangent negative? Diametrically opposed quadrants. Quadrant 2, quadrant 4. Where is tangent positive? Again, diametrically opposed in quadrant 1 and quadrant 2. So a book isn't going to write this. What a book is going to do is they're going to condense this into one answer, and they're going to take the smaller of the two angles, say 135. They're going to say, okay, it's 135 plus every 180 degrees multiple, 180 degree multiple thereafter. So 135 plus 180k would be their actual answer. So they're just, instead of writing these two, they write this one. Likewise, they're condensing for the radians. They're just going to take the 3 pi force. And they're going to say, well, every multiple of pi thereafter. So pi k is what they would write. Now, I'm not really that concerned with, doing something like this. If you want to still write it out this way, the long way, that's fine. It's just tangent, you can usually condense it because of how its solutions are set up. Sine and cosine don't have such fun things happening. Like here, we were talking cosine being positive. Well, cosine's positive in the fourth and the first. There's no easy way to write a simple multiple there. So we just say take the two angles, do multiples of 360. But for tangent, you can't actually get away with that. Particularly if it was tangent of x, something like tangent of x equals, tangent squared x, that's what I wanted, equals 1, in which case you would get tan of x equals plus or minus 1. In this case, if you would graph all those solutions, your solutions would be 45 degrees plus every multiple of 90. So solutions to this one would be 45 plus, you would see it would be 90k. You would have a solution in every quadrant, and it would be 90 degrees apart. Each solution would be 90 degrees from the previous solution, or pi force plus pi halves k. I can do this, pi halves k. Right. Again, I'm not going to nitpick here. This is, like I said, what a book would do. They like to condense solutions into the simplest possible form whenever they possibly can. We're not going to worry so much about that. Just realize that you're just doing coterminal angles, and I think we'll be just fine for these all values. Right? So it's just one more added dimension to what they could ask for our solutions. So just be prepared for that. So how do you get the all values? Well, you got to know the 0 to 360 or the 0 to 2 pi. Once you know those, it's very easy just to write coterminal angles. But that represents all solutions, all values. All right.